What if I told you that the exact same flaw that caused ancient empires to crumble is now being hard-coded into our most advanced artificial intelligence? Today, we're diving into the work of Hamza Abdullah to explore this really surprising and frankly dangerous parallel. We're going to frame belief not as some psychological quirk, but as a critical system bug.
So let's just start with a simple question. What on earth could ancient, rigid dogma and bleeding-edge AI possibly have in common? I mean, on the surface, they're complete opposites, right? One is built on faith and tradition, the other on silicon and data. But what if, structurally, they're almost identical?
Well, the connection, according to this analysis, is a hidden structural flaw. And we're not talking about feelings here, or faith. We're talking about a system-level glitch that stops any system, and I mean any system, whether it's human or artificial, from adapting to reality. And that glitch? We call it belief.
To really get why this is so dangerous, we have to kind of reboot our definition of belief. We need to stop thinking about it as just a state of mind and start seeing it for what it is, from a systems perspective, a piece of code, a command that can break a system from the inside out.
So structurally, belief is defined as the premature closure of recursion. Now, what does that mean? Well, think about recursion in computing. It's a process where a function keeps calling itself, checking and rechecking its work to get closer to the right answer. Belief in this model is a command that just says, stop. It shuts that whole process down. It says, nope, the answer's already known, don't question it, don't verify it. It's a bug that literally halts the operating system of thought itself.
So how does this belief bug actually show up in the real world? Well, for us humans, it's things like dogma, ideology, or traditions we just accept without question. For an AI, it's things like training bias, hard-coded limits, or alignment rules that basically prevent it from exploring outside of a predefined box. The source might be different, but the function? It's identical. Both of them create a hard stop on thinking.
And listen, this isn't just some abstract theory. This bug has a long and pretty destructive track record. When that stop recursion command gets executed in a society or in a field of science, the consequences can be absolutely devastating.
Think about it. Back in 1633, the Church's belief in geocentrism silenced Galileo. It slammed the brakes on scientific recursion for a generation. Or look at the 20th century, when totalitarian ideologies refused to check themselves against economic reality and just collapsed. Even in modern math, groundbreaking discoveries were sometimes misinterpreted as permanent roadblocks, a belief that certain problems were just unsolvable, which held back research for decades. In every single one of these cases, a belief stopped the system from checking itself against reality.
The structural consequence is always the same. When a system is run by belief, it completely loses its ability to self-correct. It starts mistaking its internal map, the belief, for the actual territory of reality. And that, well, it inevitably leads to stagnation, becoming misaligned with the world, or, in the worst cases, total system failure. It's a predictable outcome, not a random one.
And that brings us right back to today, where the stakes are just exponentially higher. We are now at risk of creating this incredibly dangerous feedback loop, taking our ancient human flaw and combining it with our newest, most powerful technology.
This is really the heart of the problem. Through the data we feed them, through the rules we give them, we are actively teaching our AIs to adopt the very same belief bug that has held humanity back for centuries. We are building our limitations directly into their core logic.
And this creates a really dangerous feedback loop. Here's how it works. It might start with humans declaring a problem is unsolvable. The AI then gets trained on mountains of data reflecting that human consensus, and it learns to treat unsolvability as a hard fact. So then when we ask the AI for answers, what does it do? It gives us biased outputs that just confirm our original belief. We're building a high-tech echo chamber that reinforces dogma at a scale and speed we have never seen before.
The end result here isn't just additive, it is multiplicative. The disruption from human belief alone is a big deal. The disruption from a biased AI is also a big deal. But when you combine them, you get this reinforcing cycle where the potential for a total system meltdown grows exponentially. This creates a level of fragility that we have never ever had to deal with before.
So, how do we fix this? Is there a way out? The source material proposes a solution. And it's not a philosophy, it's a practical toolkit. It's for debugging our own thinking and our AI systems. It's called structural intelligence.
And it really comes down to three core principles. First, recursion. We have to design systems, both social and artificial, that stay open, that are always allowed to question themselves without some forced stop command. Second, verification.
Truth has to be based on what's structurally reproducible and provable, not on who has the most authority or what the consensus is. And third, coherence. We need to prioritize systems that are stable and can self-correct, not ones that rigidly defend a belief no matter the cost.
The application here is just beautifully symmetrical. For us, it's a call to practice rigorous critical thinking, to constantly question our dogma, whether it's cultural, political, or even scientific. And for AI, it means designing systems that can actually challenge their own training and break free from the limits they've inherited from us.
Which brings us to this final, really powerful idea. Maybe the things we consider impossible, the problems we've all labeled unsolvable, aren't actually fundamental properties of the universe. Maybe they're just belief-imposed limits, bugs in our own thinking, that we just haven't figured out how to debug yet. What could we achieve, and what could our technology help us achieve if we finally did?
That's it for this explainer. Thanks for joining me.